So today we're just going to kind of finish up that second half of topic one, which is kind of like the Python basics. So we talked about like loops, or not loops. We talked about lists and dictionaries last time, a little bit of some Python stuff. And then we'll kind of talk about control flow, which is like for loops and if statements and stuff like that, which I believe is tied more into the Macbeth project as well. And then we'll talk about kind of topic two, talking about a little bit more of a little bit of Bash. We've already mentioned a whole bunch of it, and then we'll talk a lot about Git, trying to make sure as best as possible we can get an understanding of Git, and then we'll see if we have time for topic three. I'm not going to hold my breath too hard. I think we're going to go mostly on topic two. Okay, sound good? All right, so sweet. Let me go ahead and share my screen. And I'm just going to share my whole desktop here and Zoom. All right. You see my terminal here, everyone? Okay, I see head nods. Good. Perfect. All right. And for the record, if you say something on the chat and I miss it, just feel free to interrupt me too. Say, oh, there's something on the chat, or you had a question. All right. So I am just going to keep that up and right there. All right. And this is where we'll go back into, like I mentioned, I showed you guys last time, was the repo Flatiron School Data Science Curriculum Resources. We're going to stay mostly on this branch right here. So this is where all the notebooks are kind of coming from. And specifically, we're going to be looking at the Git folder in this repo. And we're going to talk about some of this stuff. But I'm sorry, I realized that's what we will do. But the first thing we're going to do is actually talk about the data science basics. And we're going to do the second half of that we missed. So we stopped about right here. We talked about Python basics. So I'm going to go through that notebook right now. So let's hear data science basics, data science intro, load this up. And let me just close these things since we don't need these open. Okay, that was from office hours, if you guys are wondering what that's coming up. All right, so we talked about the data science lifecycle last time. So I like this visualization, but you'll see plenty of stuff out there. I kind of like it just because it's nice, circular, and just kind of seems nice and colorful and everything. We talked about the different tools. We talked about Anaconda, setting up your Conda environment, your virtual environment. We Byron used this a lot. Not every data scientist uses Anaconda, but someone uses something like it. There's also pip install and stuff like this, where you can install packages. To make a virtual environment, you could use, I didn't mention this last time, but PVNV. But Anaconda kind of does all of it, so it's a nice go-to. And then we also talked about Jupyter Notebook, showed a little bit of things that you can do with Jupyter Notebook. We'll talk more, and we'll use this exclusively throughout the whole course. I mentioned about these extensions if you haven't seen those already. We mentioned GitHub, we mentioned some command line stuff, and we talked about some best practice for Python. And then we're going to talk about some Python basics. So we started talking about that. And let's see here. Last time we went through data types. So we talked about the main stuff, which are strings, numbers like integers and floats. There's also Boolean values and a none type itself, of course. And then we talked about some methods, f strings, listing. So we talked about listing. We went through a whole bunch of different like indexing. So if you remember this, I would say is that this can feel kind of like, I think sometimes it's going to be a little bit to take some effort to really remember how this works. I will say indexing lists and stuff like this will be really useful as we go into more data stuff, especially when we talk about NumPy, which I believe is in either topic 3 or topic 4. So kind of something to look out for. And then we talked a little bit of some more methods on list, some nuances of list within list, nested lists, and then we talked about dictionaries, right? And we talked about how a dictionary is kind of in my view, it's kind of like a generalized list, right? But basically the idea here, we have a key and a value and using that. And then you'll see that we have, for example, we can get just the keys, just the values, or get the items, which is a key value pair, which you'll see this quite often when we're iterating through dictionaries and stuff. This is a very common, what's it called? A common thing we'll do. And then I think I showed even a little bit that you could for loop, so we started introducing for loops just barely on this dictionary. So that leads us today to control flow. So the first step here, I just realized I don't have my extension loaded, but that's okay. For control flow, we're going to talk about for loops and while loops and then if statements. So it's actually kind of backwards. We're actually going to talk about if statements first. For the record, I know there's some people who already have some programming languages experience already. So if you've done things like C or Java or other programming languages, you will likely have seen for loops in a different context. I will let you know is that Python does different things with for loops. And so if you're used to seeing for loops in a different language, just know, just get ready to kind of like push that knowledge aside and leave room for special Python for loops. So that's kind of something to look out for. All right, so if statements. If statements basically work on Boolean values. So basically, this is not like, this is what we would probably say like pseudocode. This does not actually work, but it's kind of gives the idea of what's going on. We can basically have just one if statement. And basically this conditional statement, which is basically saying, hey, is this statement going to be true or is this going to be false? So this basically always evaluates to a Boolean value. Now, I'll say some exceptions to that in a second because of the truthiness of Python. And that's a technical term, by the way, this truthiness. But we have some condition that's going to be evaluated and say, if this condition is true, so basically if this evaluates to a Boolean true value, then this block of code underneath, and you can tell it's a block by it being indented, this will be executed. Okay, and note that I only have one line here, but this could be, multiple lines of code. And this will only be executed. Let's say I have like other stuff like print, X. This will only be executed if and only if this is evaluated as true. Okay. Does that make sense to everyone? Cool. All right. Now, the next step on here is that it's like, well, what if this isn't true? If this isn't true, okay, we can have an else statement. So note that else is optional in Python. So again, this is slightly different from some programming languages. And basically this says, hey, if this is not true above, then do this instead. Okay. If this else statement wasn't here, this would just continue on with, let's say, print 1. The code would just basically say, oh, is this true? Oh, it's not true. And just kind of continue down, skip over this indent block and go to this part. But an else is kind of nice is that we can actually say explicitly say, oh no, if it does not work, if this is not true, then you should do this instead. Okay, does that make sense to people? One thing to note is that this print statement, if it was outside this if, let's say I don't have this else part, this print 1 will happen whether or not if was true or if was false. Okay, so good thing to remember. And then you can see here is that I have a statement in between this, kind of sandwiched between the two, it's if and else. And again, elif is an optional statement. And this is kind of saying like, well, if this isn't true, then is this true? And this should actually be, I should put like condition statement 2. So the idea there is that if this isn't true, then go to the next block. And this is elif. It's like elif's like, well, if that's not true, is this true? And if this is true, then I'll do this guy right here. Okay. If this is not true and this is not true, then it's just going to continue downward, maybe to the else statement, or continue on the code. Note that you will only have one if and one else at most, and this if else kind of like setup, but you can have multiple elifs. So you can have like another condition 3, okay, and that will execute some other code under here. So you can have like multiple checks and stuff like this. Okay, does that make sense? Right, any questions or anything? Yes. No. All right. All right. So one thing. Oh, go ahead.
So the else would only occur if the if and all the elifs weren't true.
That's right. Yeah, it's kind of like a default statement. It's like, well, if all of those are not true, then do this instead. Okay. Note that sometimes if you're kind of a keen eye, it's like, well, what's the difference between like elif and like 2 ifs in a row, right? And the difference is that this if statement, this condition, if I did this like all as ifs, right, like this, and then let's just get rid of else just not to complicate it, is that these ifs would each have to be executed every single time. So this condition has to be looked at, and then if that's not true, then it's going to go through this. I mean, if this is true, it'll still go check this condition. And if it's not true, it'll still go on to that condition. So the elif basically is kind of a shortcut of saying, hey, like, if this is true, don't even bother looking at this stuff later on. Okay, and that's actually important because what if this conditional statement actually takes like 10 seconds to evaluate? Let's say it's doing some complicated function or something like that, is that you might not want to check the third condition if you already passed it, if you're already done. Does that make sense? So this is also a really useful control flow. That's why we have control here, basically controlling what the program does. Okay, cool. All right, so that is our if else. Let's talk about ternary operator. I don't have my code filtering extended, and that's okay. We're just going to just ignore this stuff underneath for now. But your ternary operator, which is for basically your 3-part. So this is kind of useful. Like if I would say if we were just a Python class, I'd be like, don't even bother using this. Like just like, so, I mean, some people would say don't use this because it's not as clear. But in data science in particular, it's really useful when we do one-line codes to filter through our data. So note that basically this kind of reads like a sentence, is that we have like this X part, and just I want you to focus on this right here. And this basically says it's going to be 1 if this is true, otherwise, this else, otherwise make it 0. So what's happening in this guy right here is saying, hey, X is going to equal 1 if flag is true, else X is going to equal to 0. Okay, so that makes sense, at least when I read it out like that. So we can see here, I put flag as false, I put X equals 1 if flag, else 0. What will X be? All right, I see, good. See some zeros. All right, cool. So yeah, if you do that, you should see 0, right? If I put this as true, you can see 1, right? If I say 1 is bigger than 100, is that true or false?
False.
That's false, right? So that means this flag will actually be false. And just to kind of show you a little bit, like I'll also print flag. Oops, flag. All right, and you can see here, the flag is false, which means to execute to 0. Okay, so that's the kind of idea here, is that you can do a quick check and then set this X equal to whatever to the right thing is. So this is the ternary operator right here.
So it always defaults to true in an if statement, your variable. Yeah, is that what you're saying?
Maybe you could clarify that.
Well, if flag is true, you
Mhm.
say, yeah, that's always going to mean, if you use it in that format, you're always going to say if this is true, right?
Yeah, if this is true. I could, for example, I put flag right here. I think this is maybe what you're saying. I could do something like this, right? If 1 is greater than 0, or 1 is greater than 100, like this would evaluate to false, right? So I could put it in there. But yeah, this stuff right here will only happen if this statement evaluates to true.
Okay.
Yeah.
How about if flag is equal to false in the if statement?
Can you repeat that one more time for me?
Yeah, how about you write if flag is equal to false in the if statement?
Ooh, okay. So you're saying like if flag is equal to false, like this?
Yeah.
Yeah. So we could do, let's say, for example, flag is true, but then you want to say only do this if flag is false, right? So what number would print out here? I see 0. Okay, good. Yeah, because this overall, even though the flag itself is true, this itself would be evaluated to, what's it called? That would be evaluated to false, and it can do a print, as you can see a false underneath there, right? So this is kind of like little verbose. Like you would not normally see code written this way. What you might likely see is something like not, or sorry, old habits die hard. Not flag. So the idea there is that it would be the opposite of flag. So you can see here that evaluates to the same exact thing. And it's basically saying, oh, flag is true. So it's not flag, it's not true, which is false. Okay, so that would be probably more likely what you would see in the real world.
In when the way you had it set up originally,
Mhm.
like the values for X and flag in like a truthy way, they would be the same, right? Because
Can you repeat like what exactly you're looking for? I just want to make sure I understand.
Okay, so how you had the flag equals true one originally.
Mhm.
So just because if it's true you're returning 1 and if it's false you're returning 0, isn't in a truthy way, wouldn't X and flag be the same thing? Because
Oh, I think you're saying this 1 and 0. So let me make sure I understand this, Mohammed, right? Is that I'm trying to make it clear. You're talking about truthiness because you're saying that flag, if I did, I'm trying to think of a good way to do this. You're saying that flag, the true and the one value in a lot of ways are the same value. Is that kind of what you're getting at? Okay.
Yeah.
And that's, you were mentioning about the truthiness, right? And you're right in that. So for example, if I said flag equals 1, right? If 1, like people might say, like, well, what does that mean? Well, Python interprets that as true, even though the flag value is 1. Every value in Python has a truthy value, meaning it can be evaluated as a Boolean. And that's what you're trying to get at, right?
Yeah.
Okay. So yeah, you're absolutely right. However, it is a little subtle because I couldn't just simply say, if I said flag is true like this, I couldn't just simply say x equals flag, because it will still be, it's actually a true, it's a Boolean value is true.
Yeah.
But I could, for example, I think what you were getting at is that, like, if I said something like flag is like 1, I could do something like if flag, and that would be that this would work fine, or 0. In that case, I wouldn't, this would be redundant.
Yeah.
So that can, okay. Yeah. Yeah, good to point that out. Yeah, I actually don't think I talk about truthiness in this section. But who's gotten to truthiness about Booleans? Just give me a thumbs up if we've heard this term. Okay, cool. All right, see some thumbs down. That's okay. So truthiness, which again is a real technical term in Python, I swear, I'm not just making things up. Basically, is that every value in Python has assigned truth, a true or false value, or at least can be interpreted as a true and false value. So if I say if true, just to kind of show you a little bit, print, oops, let's do a string. This is true, right? This will print this is true, right? Of course, if I change this to false, it won't print anything, right? So the thing is I like we had mentioned, 1 is evaluated as true, and 0 is evaluated as false. You can see that. Now, I said every value in Python has an assigned true and false like equivalent. So anyone guess what 10 is? I heard a soft true, which is true, right? So yeah, and it turns out in Python, every number that is not 0 is true. So hopefully that kind of, like, I think that makes some sense. Like, at least I like to reason it. It's like, yeah, if there's a missing value, we can kind of interpret that as false. So that means also -1 is true. We can do all this really fun stuff. If I talk about infinity, well, actually I don't have infinities installed right now, but we all can also do this with like none. So if none, what would we think none would be interpreted as?
False.
Yeah, that kind of makes sense, right? It's like none is kind of empty, so we want to have false. So this is actually really useful in Python data science, where we might say, hey, if there's a missing value, there's no value, we should evaluate that as false. So it's a really nice quick shortcut. There's some other weirdness too. For example, if a blank string, oh, sorry, go ahead.
Sorry, my dogs. My apologies. Sorry.
Oh, I just don't have the question. I guess the dog then. All right. If like, sorry, an empty list, that's also false, right? But if I have something in that list, we can see that's true. You can get some weird stuff. For example, an empty list within a list, or like this, because this is a real value we can do. That's actually true because there's something within that list, which can be kind of a weird kind of statement. So just be aware that, like, I would personally say for readability, don't completely rely on the truthiness of Python, because you can get some weird results. For example, you might think of this as false, but in its mind, it's like that list contains an empty list, which is a thing. So like, for example, if none, like that is a true statement because the list has something in there. So you can get these weird stuff in there. So my suggestion is always, like, if you have the option to, it helps to be extra, what's it called? Extra specific. So for example, what I really want when I do this is saying, is it empty or not? So I would say, like, len of this list is equal to 1, or should I say greater than or equal to 1, right? That's really what I'm asking. So In this case, there is something in that list, so this length is bigger than 1. So this is more preferred. But know that you can do some truthiness and stuff. Okay, cool. Yeah. For the record, remember our goal is to kind of like be able to read code better than write a bunch of code. And sometimes people will use truthiness to write very quick code, but then it's hard to read. Like if you don't remember that, you know, something like this actually will evaluate to true, you might get some mistakes. So it might be better to double check. It's like, what exactly are we asking for? Okay, cool. Sound good to everyone? Cool. All right. I love these little tangents that might not be very specific in the curriculum. So useful stuff. All right. Just another example of this ternary operator. Y, so you have y and z. Y is 10, z is 20. X will equal to y if y is less than z. Otherwise, it's z. So we can see y is less than z is 10 less than 20. Yes, that's true. So that means it should be y, which is 10. So x should be 10. Okay. Cool. Sound pretty good? Any questions on this ternary or if or else or anything like that? Okay. Cool. All right, moving on then. So the next ones, we're talking about for loops and while loops. For the record, while loops are a little less common in Python just because the way Python works with for loops. You'll see for loops tend to be a little more common. You'll still use while loops sometimes, but in my experience, I am much more likely to write a for loop in Python than I am a while loop. Just because of the nature of what we do. So a for loop is a little bit different from, like I mentioned, from other programming languages, is that you might have a for loop always loops over something called an iterable. And that is a technical term called iterable, meaning that you can iterate over it. And so the way this kind of forms this pseudocode, it's not real code, right? Is for a member in a set. And if you come from like mathematic background, a set usually means like a group of things, right? And so a set being like, oh, this is a set of stuff, and we're going to take each member out of it. And then for each member, we're going to do an operation. So the idea here is saying, okay, like if I have a list of 10 things, you're going to loop over this, do this operation, this block underneath 10 times for each of those members. Okay. And what's nice about that is that we can also, since we call this for member, we can actually do like an operation with that member, for example. So we can actually say, hey, like we're going to pull out a member from this iterable, from this set, and do something with it every time we loop over. Okay, so this will repeat over and over and over and over and over again until we exhaust this iterable. Okay, I will say is that a little asterisk, like, you know, like footnote time, is that technically it's not exhausting it. It's technically reaching a point where the iterable returns a false, saying, oh, I like stop now, which is important for some subtle things. But just know that basically you can think of it as like it's exhausted whatever was in that iterable. Okay. Again, the reason why I mentioned this because something called generators, we can have something can generate like an infinite number of things, except under a certain condition, and then it would stop this for loop. But okay, does that make sense? Cool. And again, just like always, you can have multiple blocks. So you can have multiple operations like under this block. So I can do a whole set of things right underneath that. Okay. Cool. So let's try to see what this looks like in practice, right? So I have lower cities and I have nothing in there. So I'm just going to making a blank list, and I'm actually going to populate that list by adding things into it in my for loop. So remember we have travel cities, which I just realized I do not have that part executed. So let's actually execute this. It would have given an error otherwise. So my top travel cities are all these cities. I think there's 11 different ones here. And let's go back down. There we go. Sorry, I just wanted to make sure I executed that part. So now I'm going to go for travel cities. There's 11 different cities. It's going to pull from that list. And just to remember travel cities, there we are. It's going to pull each one in order when it loops over. It's going to say city is going to essentially, it's essentially saying city equals the first element, city equals the second element, and so on. Okay. And then I'm actually going to do something with that city. In this case, I'm going to do lower cities, which is this list right here, dot append. So that means I'm going to add whatever comes next into lower cities. In this case, I'm going to do city.lower, which remember, this should all be strings. So dot lower will make this lowercase of the city, if we pull it out, and it will be added into lower cities. Okay, does that make sense? All right, so just to kind of show you what that looks like, if I run this now, you can see now I have lower cities, and it's basically that same list, but lowercase. Okay, makes sense? Sound good? Cool. All right, so one thing we could also do is actually specify saying, well, okay, I don't want this list. I want, a slice of that list. Let's say I only want the first 5 of it. Well, we know how to do that, right? We could, for example, do something like, let's say short list. We could do something along the lines of, oops, sorry, didn't mean to do that. Oh, sorry. I keep it's a little muscle memory. I keep doing shift enter because then my program will go up. Short list equals this list, but only the first 5 elements, right? And that would basically do that. And then say, okay, then I get only the first 5 elements in here. Okay. But remember, it's like it's kind of long. This is kind of not needed. I'm only going to use it once, just iterate over it. So what instead I could do is I could actually take this guy and say, hey, you're just going to be a list of the first 5 anyway. Let me just put that in there. And then I run this, and you can see it gives the same exact output. Okay, you see that? So let's say I wanted the lower cities, but I wanted to put it like, I don't want to start with Solta. I want to start with Pio Chang, right? How would I do that? What would be a simple modification to this code?
-1.
1.
Yeah, so we could do like you said, -1 1, but I'll just make it even shorter, just :-1, right? We talked about last time, and there we go. It just says, all right, read this list in backwards, right? It's going to return that list backwards, and then just do it for each city. So then we get it appended in each part.
For the city after 4, is it just a placeholder to describe the members in the list?
That's right. I could call this like flip-flop. Right? It'd be the same thing. Nice, right? Okay. Which I'm glad you brought that up, Becky, because there is something you can do as well in for loops, which you'll see quite often in some cases, and I have to actually get rid of that comment underneath there. Let's say I want to do something like just print, I don't know, hi. Okay, I want to print hi however many times. I want to print hi, and I'm just going to get rid of this -1 because we don't need this right here. I want to print hi for every city there is. Right? I don't care about what city it is, just want to say the word hi. Well, I could do this, right? Flip-flop, or I'll put it back to city to make it more understandable. City in top travel cities, print hi, right? And it'll do this 11 times. Boom, 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 right? No, that's because there's nothing in here. So, but this city, it's like, I don't know. It's one of those things. It's like it's a little like unnecessary. Like, do I really need to call it something if I'm never like if a tree falls down in a forest and no one's there to hear it? Does it really make a sound? That's kind of the idea of the city here right here. It's like it's not doing anything. It doesn't matter what we call it. So what you'll see in Python a lot, we'll actually just give it an underscore. And what that means basically says, hey, you're still going to do a for something in this list, but like you don't need to call it anything. Like just don't worry about what it's called. Just do this so many times. And you can see here, it'll produce the same thing, hi 11 times. So this is the equivalent of having that tree fall in the forest with no one there to hear it. Okay, and then I think I saw a hand raise. I didn't see who it was.
I was just, as long as you're consistent throughout the function, essentially what that's doing is just basically, you can call it whatever, it doesn't really matter as long as you keep using the same reference. It's just cycling through top travel cities repetitively until it gets whatever the desired function is, right?
Right, you're talking about like this name right here.
Yeah, like city essentially, or you can call it X or Y, but as long as you're consistent throughout the function, all it's really doing is that it's just going through top travel cities until it meets the desired goal of the function, right? So
exactly. So it's just a reference for us. This is kind of equivalent, like this would be redundant, but would it be like something as if like you were to go like city is equal to, and then like top travel cities, the first one, right? And then executing code. And then the city, top travel cities #1, and then executing the code. That's essentially what's going on. For people who have other programming languages under their belt, you might have actually done this, and usually you'd see something like I, like this would be like I, saying like, oh, this is the ith index, and reference it this way. But since Python's like, oh, lists are really cool, and we like lists, it just lets you, it actually forces essentially an iterable to be iterated on the for loop. So yeah. Well, but you're absolutely right, Sam. Doesn't matter what you call this. Cool. All right. All right. So here's a little more
One
complicated
question.
one. Oh, go ahead.
So in that, if we replace that city with I, the I is index or the item?
Good question. So the question is like, if we replace this for I in top travel cities, what is I? And so you say, oh, is it the index, like I said? And it's actually not. It's actually just, oh, I have this printed.
Item.
It's just the
Yeah.
actual item, the element itself. So I'm going to show you something since this was brought up. This is something you might also see. You will also can have, let's say I'm going to back up just a little bit. I'm going to come back to what was just asked. So let's say, and I'm going to make this completely new list just to kind of show an emphasis of something. Say new list. My variable names are very creative, as you guys can tell. New list. And I'm just going to say this new list. Remember I mentioned tuples before. I'm going to have, let's say 1, comma 1. Okay. And then we have, let's say, oops, 2, comma 2. And I realized that I was not a good programmer and did not start with counting with 0. I'm going to put 0 here. 0, comma 0. Okay. So hopefully no one's like has like not looking at the screen now. 0 and then the string 0, like representation of 0. So this is actually a list right here. And if I were to print out, if I were to print out new list, you see here that I have elements in here. How big is this list? Like, what is the length of this list? I see some people going like 3. Yeah, 3, right? So yeah, if I do the length of this list, it is actually 3 elements in there. And that's because each of these guys right here, this is one element, right? It is what we call a tuple, right? I could have done other lists within lists, but tuples are nice because I have this as one element in that list, right? So I could do a for I. I'm just going to put 4 elements just because for element and then oops, print element, right? And this will show 0, 0, 1, 1, 2, 2, right? Makes sense. It'd be really nice. Like you'll notice that I put this on purpose, like 0, 1, 2. It would be nice to like, let's say I want to actually get that number out. Like I want the number itself. I could, for example, do like print element, the first one, and then let's say print, I'll say like, let's do an F string. Word is, and then element 1. Okay. And so hopefully this makes sense when I'm reading this out right here, is that this is going to grab this element, which is going to be 0, 0. It's going to grab the very first one, which is this 0, right? So it's going to print the number 0. And then the second part is going to print word is, and then it's going to get the second element, or sorry, the second element within the element. Hopefully that makes sense. So you'll see 0 here. So I'll say print is, or word is 0, word is 1, word is 2. Okay, so if you see this, and I'll just put a print just to make it clear. You can see here, the first one is 0, word is 0, 1, word is 1, word is 2. So this is kind of the idea, like I think it was mentioned, like well, it would be nice to have an index, right? And it's like, oh, I have to put this in myself, right? You can see, like if I wanted to index that, it'd be kind of annoying. Like I could maybe do a counter and do some weird stuff. There's a bunch of crazy things you could try doing. But what would be really nice is if we actually just go enumerate. So enumerate is a reserved word in Python. And enumerate, if you can kind of hear what the word sounds like, enumerate is basically saying, like labeling this with a number, okay? Enumerate that list. So I can have now my list of, what do I have? 0, oops, 1, and 2, right? And so now what's going to happen, if I run this, you can see it did the same exact thing as I did before. And that's because if I actually print out the element, it's actually doing exactly that. It's actually putting a 0 in the first one, and then the second one's going to be a 1 in front of it, and then a second one's going to be 2. Okay, so it's actually a really convenient way to actually get an index. If you want it, if for some reason you want to keep track of where you are in your iterable, you can actually pull this out. And this is where Python is really powerful, is that we can see I have this element, I could pull out, element 0, element 1, which again is kind of clunky code, right? So I could be like, well, okay, let's say do element, this is the word. and I'll say element 1, or sorry, word is equal to element 1. Okay, and then let's say number, I'll just put num, is equal to element 0. And then I can put num here. And so this is a little more readable as like, oh, what I'm expecting the code. I can look at this very quickly and see, oh, I can see what's being trying to set each time, right? Is that this should be a number, which should print the number, and then should be the word, it should print out the word. And of course, that's exactly what happens here. But you can see it's like, oh, I have to still do this extra stuff, which is not bad, but it's like a little extra work. So Python, if it knows that there's going to be like 2 elements, right, as being passed through, so there's like a list of things, you can actually put in num, comma, word. And then I can get rid of this guy. And Python knows like, hey, like in this enumerated list, when I pull out the first element, it's going to have 2 different things, and it's going to match num to the first one and word to the second one. And so now when I iterate this, well, this is not a good example of what happened here. Oh, I'm using element still. This should actually be, I guess, num word. So we'll just get rid of this. It's referencing element from the last one, which we got rid of. So that's why it's got that 2 there. But if I run this, you can see num 0, word 0. And you can see it's just doing that each part. So that way I don't have to, you can see this code's really readable, right? You basically say for number and word in a enumerate list, print the num, print the word. And now we have something that's actually really concise, and we get something that's, you know, equivalent to index. So going back to the idea of I, you can have I here. Okay. How's that sound to everyone? Sound pretty good? Kind of confusing, or like, I'm lost. I think
So
it's almost, okay, go ahead.
In each version, you're just for the enumerate, you're just enumerating the tuples. Like, so 1, 2, 3, or 0, 1, 2.
Yeah, so I'm just, in this case, it's just a string, right? But yeah, if I'm essentially making a tuple or a tuple, it's either way, from this list right here. So this new list becomes this enumerate new list. Like I could actually, I believe I can just write this like this. Oh, of course I didn't. I have to put Python 3 is just too smart. There we go. You can see it's basically the list I just made. Cool. Awesome. All right. Now this also can work if you had 3 elements. If I had, for some reason, 3 elements in there, I could technically have, you know, I, J, and K, and I could have 3 different ones, or however many you had. Note that if I did try, I'll just show you just real quick. If I did have a 3rd one in here, this won't work. It'll get upset at me. So, hey, not enough values to unpack. Expected 3, these 3, but only got 2 because the enumerate list gets 2. Okay, cool. All right, cool. All right, I'll move on to the next part. I know we spent a little extra time, but it's kind of fun tricks you can do with Python. Okay, cool. Let's see here. Let's see what this next part. So this is kind of the idea. I think you guys probably been staring at this for a while, so I'm sure some people maybe already looked this over. But let's see. So we can set the index for, this is essentially saying, could we make a for loop out of a while loop? So we could technically do this. So this is actually, let's see here. I think I wrote a couple things on here. So let's say I have I equals 0, lower cities equals a blank list. I'm going to add it in there, and I'm going to actually comment out this guy and say while I is less than 5. Okay, first of all, I'm going to increase it by 1, and I'm actually going to put this. I realize I did this because I wanted to show how you can break things, but we're going to skip over that since we talked a whole bunch of extra stuff, which is, I think, cooler. If I do this and then I say city is equal to, what was it? What was the name of that list that I had way back? Top travel cities. This one right here will say, okay, I start with 0. I have a blank list. While I is less than 5, basically it's going to loop through until I is or while I is less than 5. So we'll keep doing this as long as this is true. It'll say, okay, city is equal to top travel cities, get the ith element. So note that it'll be 0 first, so get the first element, right? And then lower cities dot append city, which we put it here, dot lower, and then it'll show you as print lower cities. It's going to make a list that's going to be 1 element long, 2 elements long, 3 elements long, and so on. And then each time it iterates through this loop, it's going to increase I by 1. So that means the next time I was 0, it'll go up to here and say I is 1 now, and say is 1 less than 5? Yes, that's true. Continue going forward, it'll keep going until I is not less than 5. You can see that's what we get here. Okay, cool. That makes sense. I kind of went through that pretty quickly, but hopefully you kind of see what this is. Really, the while loop is just saying, is this condition true? If this condition is true, just keep going. Yeah. All right, cool. And this is kind of like, you can see a little bit, like I can make this equivalent, this while loop and this for loop equivalent to each other. But in Python, for loops just have this extra power. So you'll see for loops a lot more than while loops. Cool. I'm going to go through this really quickly. I just know while loops basically say while condition. I know that we do things like conditions like this. So greater than, less than, this should be a comma. Greater than, less than, greater than or equal to, less than or equal to, equal, or whatever kind of Boolean value is up there. It'll check that condition. And if that condition is true, just keep on going. Okay. There is an exception to this, is that if it sees a break statement, it will actually stop and distract it. Oh, wait, someone told me to put on the brakes. And it'll actually stop right there, and it'll basically break out of that loop. All right. Sam L raised their hand.
So I was working on some Code Wars stuff, but then like when I used the while loop, it would go over the time limit sometimes.
Mm-hmm.
And when I was looking it up on Stack Overflow, people have said that because while loops take such a longer time than other loops, they said that they would recommend using for loops instead of while loops. Is that true, or like?
So it can be, in short. Like effectively, it looks very similar. But the difference is I'll show you like from here, is that in a for loop, we are actually saying, hey, like basically all it's saying is like, give me the next one, right? And then I'll do whatever you want. And then give me the next one, I'll do whatever you want, right? And then it gets to the end, it's like, oh, I don't have any more. All right, let's stop the for loop. So it turns out computer-wise, when you ask for give me the next one, that's actually usually a very quick thing for it to do, especially in Python with iterables. It says, oh, just give me the next one. It can do that very, very quickly. A while loop has to check this condition every single time, right? So for the most part, this condition is like relatively quick. Like doing I less than 5 is like milliseconds, if not nanoseconds for Python. But if you had a very complicated function that, let's say, imagine a function that said, this function is called like, is this true? And you gave it a value, that thing might actually, that complicated function might take a long time to execute, and it might get even worse as time goes on, versus where just give me the next one is actually in Python relatively simple for it to do. There's a whole bunch of computer science why that happens. But I would say in general is that most of the time when we're talking about while loops and for loops, this condition is relatively small, where the difference is probably minuscule. Technically, like depending, like, you said like, oh, you timed out. If your timeout is like in milliseconds, like this could technically be too slow, and the for loop might actually go faster. The other issue with the while loop is that this will keep going as long as this is true. And there can be issues with that. For example, if I say I is equal to 5, like this, there's actually a very subtle point in here. And it comes down to the fact that computers are not very good at keeping track of decimal point numbers. This is something, if people have learned any computer science, this is not necessarily programming language, is more like kind of computer science, is that the way you store a 10-digit number, base 10 number in binary code, like ones and zeros, is actually not I shouldn't say precise, but you have some issues with something called like floating point precision. And the problem with that is that like Python 3 is a little bit better at this. Python 2 was notorious for this. But like when I do like 1.5 times 2, you would say that's 3, right? And it is 3, but the computer says it's 3.0, which doesn't seem like a big difference, but it ends up being a big difference because how does it know like when to stop that decimal point? Like if you had a very long decimal, it might actually say, well, I can only store 12 decimal places, but the 13th decimal actually is when it's different, you can get some issues where you can have an infinite loop because it never quite is 5. It's like 5.000001 or 4.9999999, and it won't round up and stuff like that. Which is another danger of like why while loops can be kind of like, you can get these weird cases. That's a little bit separate from what you were asking though, but that's another thing that could come up where it ends up going forever because the way it's specified. Hopefully that kind of answered the first part of this, answered your question, hopefully.
Yeah. So should we actually use while loops when we're
so
as a data scientist, since it doesn't really, or since
this question is like, hey, should I use this? And my answer is probably like, you probably won't have to use it. There might be some cases where it makes sense, but I personally rarely use while loops because they rarely end up being an issue. I usually know, like, how do I say this? This is where I'm going to go in more like details of like things that we haven't talked about and might not be talked about even this whole course. Something called generators. If you guys are wondering what it is, Python generators is kind of a better solution than while loops, because a generator basically can go on infinitely if it wants to, or we can have stop conditions within the generator itself. And what that means is basically you have a for loop. And remember I said like, give me the next one. The generator can make up a next one and can keep giving you the next one, the next one, the next one, the next one. And that's a lot easier to control than looking for a specific condition that needs to be met or needs to fail to stop. And I know that's a little over your head, but like, you guys don't know what Python generators are. My suggestion is probably in general, if you can do a for loop over a while loop, you probably will go for the for loop. Okay, cool. I also, there are some cases where this makes sense, but at least in data science and in my own experience, it's usually infrequent. Okay, cool. All right, hopefully it suffices to me. Like, don't worry about it is basically my answer. But yeah, while loops, not so much. It is good to know though. Like I said, one thing, this is another example. It's just basically counting down. So you have another way to reach the end of it. And then you can see here, I have a few other examples where you can have a break statement. So for example, it says while I is less than 10, but if I is equal to 5, right, which, you know, we talked about some issues with this, but this should work fine. It's equal to 5, it'll actually break early instead of going all the way to 10. And you can actually see is that it keeps going 0, 1, 2, 3, 4, 5, reaches to 5, says, hey, if I is equal to 5, break free. So this could be something like if something fails or if a certain condition is met, you could say, hey, stop going forward. Note that you can also use break within a for loop. So you can actually say, oh, if this happens in a for loop, just stop right now. You don't have to keep going. So this is useful not just for while loops, but also for loops. Okay. The opposite of this is a continue phrase. And so you'll notice here is the same, kind of a similar idea. And in this case is that if I took this out right here, I'm just gonna take this out, is that you can see this is just going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, just goes all the way through. Now, if I did, for example, this guy right here, counter, this is modulo, basically percent sign, modulo 2, is basically saying, hey, is this divisible by 2? What's the remainder after dividing by 2? If that remainder is 0, this is going to be equal. Like this will be true. So basically, this is saying, hey, is this even? And so if it's even, do this. So I could do if it's even, break. So it'll print out 1 and then stop, right? But let's say I just want to skip the even ones. I can do continue, right? And you can see here, it only prints up the odds in this case. It basically says, if it hits, if this is true, just continue on to the next part of the code. Like just ignore this part, right? And you can see it continue, I would say not continue the next part of the code, continue the next loop. So you can see it basically skips this completely, does not print I, right? And then goes up to the top. So this is useful. I personally don't like using continue because it does add a little extra complexity. I think a better way to write this, for the record, would be something that looks like this. If I is greater than continue, and I only want to print out the odd one, I would just basically say if counter is doesn't equal 0, print that. And you can see I get the same results. Like to me, that makes more like direct sense. I'm saying when this happens, do this thing, versus like saying, if this happens, don't do this thing and continue on, because this is easy to accidentally misread or skip over. but it is sometimes useful. Okay. Cool. All right, I know we're at the hour right now, actually almost exactly at the hour. But for the record, future study groups will be closer to an hour and a half, but I wanted to make sure you guys all at least had that first hour and if this. But do you have any questions on anything we talked about so far today? No, pretty good.